The chapter light consists of five huge units. The first unit talks about the refraction of light, that is bending of light when it passes through a transparent medium. The second unit talks about real and apparent depth when an object is immersed inside any kind of liquid or even in air. The third unit talks about a special kind of a reflection that is known as total internal reflection, which takes place within the denser medium. The fourth topic talks about deviation through a prism, that is bending of light when it passes through a prism. The last one talks about refraction of light through lenses. Few properties of light that we have already studied in lower standards and that we are supposed to remember. First one, light travels in a straight line, which is also known as rectilinear propagation of light. Whenever we draw ray diagrams, we are supposed to draw straight lines with an arrow. Light is also an electromagnetic wave. That is, it is not affected by electric and magnetic fields. Light can travel through vacuum. It does not require a medium to propagate. Very much unlike sound, because we know that sound requires medium to propagate. It cannot travel in vacuum, and hence sound waves are known as elastic waves or material waves, while light waves are electromagnetic and hence they can travel through vacuum. Light has the highest speed in vacuum or air, that is 3 into 10 raised to 8 meter per second. And if light travels into any other medium other than air, its speed decreases and hence it bends. This bending of light is known as refraction. Refraction of light through a glass slab. Glass slab is a rectangular piece of glass as shown here. You can see the diagram on the right hand side and the diagram on the left hand side bottom. These are two diagrams related to a glass slab. When light travels from one medium to another, a part of light energy is reflected at the interface of the separation of the two media, and the remaining part is transmitted through the second medium, which is deviated from its original path. Consider a ray of light going from medium 1 to medium 2 as shown in the first diagram. So this ray of light that is coming is known as incident ray. When the ray of light is incident at this boundary of two media, this boundary is known as interface. A part of light undergoes reflection. So this ray 2 is the reflected ray that is bouncing back in the same medium, while ray 3 is the refracted ray that is transmitted through the second medium, which is a transparent medium. A transparent medium may also be known as optical medium. So we should not think that the ray of light is fully transmitted or fully refracted. A part of light is also reflected back into the same medium as shown in the diagram. Let us go back to the definition of refraction. The definition says, the phenomenon due to which a ray of light deviates from its original path while traveling from one optical medium to another optical medium is called refraction. So this bending of light, when it goes from one optical medium, one transparent medium to another transparent medium, is known as refraction. Why does light bend? This change in the path of light occurs due to the change in the speed of light in the given medium. This bending is occurring because the speed of light is changing. And why is the speed of light changing? Because there is a change in the density of the medium. Whenever light travels from air into any other transparent medium like water or glass, it will always slow down. Important. During the action of slowing down, the wavelength of light changes, but the frequency of light remains the same. One quantity that changes is wavelength, and one quantity that does not change, that remains unaffected, is the frequency of light. Also, consider the diagram on the left hand side bottom. If we talk about a ray of light that is coming straight, so we consider a ray of light coming straight When it is coming straight, it is making an angle of 90 degree with the glass slab. This kind of incidence is known as normal incidence. In the case of normal incidence, the ray of light does not bend, although there is a change in the density of the two media, and the ray of light passes undeviated. Again, when a ray of light is incident normally, it can be from the top or from the bottom as well, as we can see in the diagram. If the ray of light is incident normally, it passes through the glass slab without any refraction. That is, it passes through the glass slab undeviated. In this case, angle of incidence and angle of refraction are both 0. If we consider another case, the ray of light is incident obliquely, as you can see in the diagram on the right hand side. Here, the ray of light is incident obliquely, and this is known as oblique incidence. When it is going from rarer medium to denser medium, that is, in this case, it is going from air to glass. Air is a rarer medium because it is a gas. Glass is a denser medium because it is a solid. So when the ray of light is going from rarer medium to denser medium, as shown in the diagram, it bends slightly towards the normal. In this case, angle of refraction becomes smaller than the angle of incidence. At the second interface, it is now traveling from glass to air. That means it is going from denser medium to rarer medium. And it goes from denser to rarer medium. As shown in the diagram, it is bending away from the normal. Here, angle of refraction will be greater than angle of incidence. We should remember again, when the ray of light goes from rarer medium to denser medium, it bends towards the normal. That is because its speed decreases. When it goes from denser medium to rarer medium, it bends away from the normal. That is because its speed increases. So if we talk about conditions when refraction is not going to take place, suppose somebody is asking us, state the conditions when refraction does not take place. So the first condition from this diagram is ray of light should be incident normally. Second condition, if both the media have same density, again refraction will not happen. Going back, so we should remember the change in the path occurs due to the change in the speed of light. And this change in the speed of light is because the density of the two media is changing. So if the ray of light is traveling from air into water or glass or oil or kerosene or petrol or any other optical medium with a higher density than air, it is definitely going to slow down. Still continuing with the same refraction of light through a glass slab. When the ray travels from a rarer medium to a denser medium, for example, it is traveling from air to glass, it bends towards the normal. When the ray travels from denser medium to rarer medium, for example, it is traveling from glass to air, it bends away from the normal. Two things to remember. When the ray of light is traveling from one medium to another medium, it definitely bends. The direction in which the ray of light bends will depend upon two factors. Number one, the medium through which the ray of light is traveling. That is, whether it is going from denser to rarer medium or it is going from rarer to denser medium. Number two, it also depends upon the optical density of the two media at which refraction takes place. Density again always is an important factor because refraction of light essentially takes place due to the change in the density of the two media. Another important topic. When the ray of light travels from rarer to denser medium, it definitely slows down. How much the ray of light slows depends upon three factors. Again, number one, just like I said, optical density of the medium is the most important factor, obviously, due to which refraction takes place. Number two, the bending also depends upon color or wavelength of light. For example, We know that when white light passes through prism, it is split up into 7 colors. Have you ever wondered why red color is at the top and why violet color is at the bottom? That is because red color has a high wavelength. Since it has a high wavelength, its bending will be less. Its deviation through the prism is less when it is going from glass to air, and hence it remains at the top. While violet color has a lower wavelength, and hence its deviation or bending will be more. So it comes at the bottom. So the second factor, slowing of light depends upon color or wavelength of light. We should remember that the subjective property of light related to wavelength is color. The moment wavelength changes, the color of light changes. And the third factor on which refraction depends or bending of light depends is the temperature of the medium, because a slight increase in the temperature would change the density of the medium. We should remember that hot water and cold water had different densities. Hot air and cold air both have different densities. So again, refraction of light or bending of light or slowing of light depends upon three factors. First one is the optical density of the medium. Second one is the color or wavelength of light. And third one is the temperature of the medium. Laws of refraction. Just like we have two laws of reflection, we also have two laws of refraction. The first law is an important law which was given by Snell, and hence it is known as Snell's law. It states that the ratio between the values of sine of angle of incidence and the sine of angle of refraction for a given optical media is a constant quantity. This constant quantity is known as the refractive index of the second medium with respect to the first medium. So we come to the equation of Snell's law that is given on the left hand side. It says that mu, which is the symbol for refractive index, is equal to sine of I upon sine of R, where I is the angle of incidence and R is the angle of refraction. And this mu for a given pair of medium is always a constant quantity. Like for example, mu for glass with respect to air is always constant, that is 1.5. Mu for water with respect to air, that is 1.33, is always fixed. Remember, refractive index, that is mu, is always a constant quantity. And this was discovered, this is given by Snell's law. Again, mu is equal to sine I upon sine R, which is constant. Now, suppose if the ray of light is going from air to glass. I'm talking about the second equation that is given on the right hand side. If the ray of light is going from air to glass, first medium, air, that is written as superscript. Second medium, that is glass, is written as subscript. So we read this as, and refractive index is always for the second medium with respect to the first medium. So how do we read this? I'm going to read it as refractive index of glass, that is my second medium. Refractive index of glass with respect to air is equal to sine I upon sine R, according to Snell's law. So that was the first law of refraction. The second law of refraction, which is very similar to the second law of reflection, it says that the incident ray, the refracted ray, and the normal lie in the same plane at the point of incidence. The only thing is we have replaced the word reflected by the word refracted ray. Again, the second law says the incident ray, the refracted ray, and the normal lie in the same plane at the point of incidence.